Hi, this is Pragadisharan K. Now I am going to present my project titled Brain Tumor Detection using level set algorithm. Generally, image processing is used to investigate the different abnormalities like tumors, vessel blockages, fractures, etc. Here I am using level set algorithm to detect the brain tumor. Of the paper is to partition the digital image into multiple segments so that I can extract the desired region of interest from the given image, and to change the representation of image into something that is more meaningful and easier to analyze. This is done by finding the boundaries of the given image. Once these boundaries are found, it is easy to differentiate the tumor from the given image. The most important fact is that while simplifying the image, we should not discard any important features. The basic concept of the level set algorithm is applied to segment the tumor from the brain. As we all know, the brain is the complex part in the human body because it consists of n number of crusts and troughs. So imaging this brain and detecting the tumor in the brain is a difficult task. Brain tumor MRI exhibits a complex characteristics. It never have a regular boundaries. It always has an irregular boundaries. So separating the brain tumor from the brain is always a complex task. If the tumor size is small, when it is less than 3 millimeter, it will even more complex. So this methodology, level set algorithm, is accurate and efficient for this type of highly complex settings. The entire workflow is divided into 4 stages. Input stage. In the input stage, the data are received from the MRI images and it is sent to pre-processing stages. While pre-processing, the noises are removed and the morphological operations are done. Then it is sent to an extraction stage where the features are extracted by level set algorithm and thresholding segmentation. Finally, it is sent to the output stage where the segmented image is shown. MRI images is usually corrupted with an n number of noises like magnetic field noises, electric field noises, etc. So we are using different types of filters to remove different types of noises. Here we are using median filters to remove the magnetic field noises and spatial filters to remove some electrical field noises and artifacts. Sobel operator, which is used as an edge detector and which acts as an edge preserving biaxial filter here. Operations, only very less information of the image is present in the background. The major information is found only in the foreground. So these morphological operations remove these unwanted informations in the background. The morphological operations such as dilation, erosion, opening and closing entirely performs surface cleanup and image masking. In most of the cases, these morphological operations acts as a filters and removes the unwanted noises in the given image. After the image undergoes a binarization, it will goes to the thresholding. This thresholding is also called as intensity based segmentation, where we are fixing a threshold value. When the intensity values below these threshold values, it will become more darker, and when the intensity values is above the threshold value, it becomes brighter. So this helps to extract the region of interest from the background. It has an n number of advantages such as small storage space, easy manipulation and fastest algorithm. The level which is used to partition the images into subregions with continuous boundaries. A continuous contour is fixed at the edges of the image and they start moving towards the center. While coming to the center, if these contours faces any sudden changes, these contours will stop and it encircles the given region of interest. The first image shows the initial curve where you can see the circle contours which is fixed over the images. This is a circular contour these contours are start moving towards the center. Here the contours face as in sudden changes in an intensity. Here the pixels values is changes suddenly, so they stopped moving towards the center. Then finally the region of interest is detected. Normal images, these are where there is no tumors are here. These are all the, in most of the algorithm, while detecting this tumor, this algorithm also detect these as also as a tumor. This is a wrong perception, but this level set algorithm will detect only the tumor region. This image, the foremost task is to detect this area of tumor region alone. Converted the grayscale image into black and white images, but the density of the skull is reduced. So by dilating this image, I can improve my density of the skull. But while dilating, the noises is also get amplified and it become more darker. So the next I perform thresholding for this image. So I set the threshold value as 800, so these unwanted noises are get removed. In the second stage of the thresholding, I set the thresholding range as 3000, so this tumor region is also get vanished. Now I subtracted this image from this image, so that I get only the tumor region. But this tumor region has both white and black pixels, so I want to enhance this tumor region to detect the tumor in the normal image. So perform here. Sobel operator acts as an edge detector and it detects edges, but there will be some holes, so I dilated the given Sobel operator's output, so there will be no holes here. Now I perform masking for this image, segmented image, where I performed masking for the previous image. Now I compare this image with the original image, so I outline the tumor region alone. Now I want to differentiate the tumor region with the normal region. So in morphology, this red color indicates the tumor region, while the blue color indicates the normal region. These are the hope my accuracy level will be more than 85%. The references where I gathered knowledges on the image processing.